So section 1, I'll call Intro to Statements. So let's define what that means. A statement is a sentence which is, or are if it's plural, unambiguously true or false. Never both. Okay? So I'm going to pull up a couple of examples with some movie magic. Okay, so here are some examples. Decide if you think these sentences are statements or not. And if they are statements, whether they're true or not. So this is where you would pause the video, try it on your own. 3 is an odd number. So that's a statement, and that is true. I'm just going to shorten them. 3 is an even number. That is a statement, but it is false. 3 is a cool number. So let's go back to what our definition of a statement is. It needs to be unambiguously true or false. So there might be big fans of the number 3 or big haters of the number 3, but it is ambiguous. So it is not a statement. Okay? Are there 3? Not a statement. Danica has 1 strand of hair. So I know that might sound weird, but it's just something very easily noticeable about me. I have a lot of hair. And this really trips up students every single time I teach this class. So I ask you, does Danica have do I have 1 strand of hair? And a lot of people will say false, but in fact it's true. Look, I just found one. Okay, so then what I do is I ask my students, can you think of one word that we could add that would make this statement false? At least for right now, hopefully for a long time to come, but. And so my students typically come up with, so let's, for right now, the statement is true. But if we add one word, and that word would be exactly. So Danica has exactly 1 strand of hair. Well, right now that's not true. Here's 2. Okay, so I know I have more than 1. So it's statement and it's false for the time being. Okay, this statement is false. So now this one is a little tricky. So if it was true, then the statement would be false. Okay, but if it was false, then the statement would actually be true because it said it was false. So this is actually not a statement, but it's actually something special. So not statement, it's actually something special. It's called a paradox because it's true and false at the same time. So My Nose Will Grow Now by Pinocchio. So if you don't know, Pinocchio is a little puppet, and every time he lies, his nose grows. But if he tells the truth, his nose doesn't grow. Okay? So if he was telling the truth that his nose is going to grow right now, his nose wouldn't grow because he was telling the truth. Well, if he lied about it, then his nose would grow. Oh, but then he'd be telling the truth because he said his nose was going to grow. So once again, this is not a statement, it's a paradox. I think those are fun. Okay, on to the next thing. So I'm going to make a remark. When we talk about statements, we don't always want to rewrite the whole sentence or sentences every single time. So instead, what we can write is we can say P, so remark. That's my shorthand for remark. It's supposed to be an RMK. So usually we use capital Latin letters. So here I've used a capital P. And then I've written a colon. Okay, so this reads P is defined as, and then I'm going to write a statement after. This doesn't make sense if you don't write a statement, okay? So I wouldn't use one of the paradoxes or one of the not statements. Okay, so let's say 3 is an odd number. Okay, another way we can write statements is like this. And so remember, I'm doing the dot dot. There's no equal stuff because that doesn't really make any sense. Okay, we're saying that P with value X is defined as, and then let's say X is an odd number. And so once again, we would only be plugging in things that make sense. P is true. Let's say P of 5 is true, and P of 2 is false. Okay. So we call this P up here a quantifier in this situation. So P is a quantifier. So that's the thing I was talking about. We usually use capital Latin letters. Okay. P of X is a conditional statement, okay? Because whether it's true or false depends on what X is, okay? Like above I said, P of 5 is true, but P of 2 is false. All right, so that's the end of our talk about statements for now. So now I'm going to go into section 2 and call this Intro to Sets. So how I'm going to define sets is a set is a collection of objects. Usually we call these elements. Sometimes I shorten elements to ELTS or ELT for element. The size of a set is called its cardinality. And this is written for a set A, let's say. We would write that. And so you just count up how many elements it has in it. And if the cardinality is less than infinity, then we call it a finite set. If cardinality of A is less than infinity, then if not, then it's an infinite set. All right, so again, I'm going to bring up some examples. Okay, so with these examples, you could pause it now and just try to figure out what the cardinality of each is. Okay, so the cardinality of A is 3 because we have 1, here let's zoom in. 1, 2, 3 elements in there, okay? So now the empty set. So when I think about sets, I often think about like a bowl, and then the stuff you put in the bowl are the elements, okay? But the bowl and the elements are the set, okay? So the empty set is just a bowl with nothing to choose. There's no elements in it. So you can grab in all you want, but there's just nothing, okay? So it's the set with no elements inside of it, okay? Therefore, the cardinality of the empty set is 0. All right, so I suggested to picture it on the number lines. Let's say this is 0, this is 1, this is 2. Then what is B? Well, B would be open, both on 1 and 2, but it'd be all the numbers in between. So man, that's a lot of numbers. Cardinality of B is infinity. I know mathematicians, we often cringe when we say infinity equals something, but you get my gist. For C, it's going to be similar. It's just going to look different. So remember, the hard bracket means we're including that number. The soft means we're not including that number. Okay, but then these kinds of brackets just means we're counting stuff. So here's how I would write A. Big bracket, slightly smaller one, the same size as before, slightly smaller one. Okay, so you notice it's slowly getting bigger, right? So that's just to keep it clear in my head what the heck's going on. So you might be looking at this and saying, wait a second, but that's a set. That's true, but right now we're considering it as an element of A. Okay, so the set containing 1 is an element of A. Maybe picture it as a tinier bowl inside of A with the lid on. Okay, because that doesn't, just because you have the set containing 1 as an element in A doesn't mean that 1 is an element of A. In fact, 1 is not an element of A here. Okay, so what you could do as kind of a cheat around this is look at the number of parentheses. Okay, all right, so I know I'm going to have 1 element between each parenthesis. So actually, just as before, the cardinality of A is 3. Okay. How do we write that something is an element of a set? Notation. If X is an element of A, then we write okay. So if you saw that, it was just a little curl. like a C and then a line through it. Please do not write that, even if you write it smaller than I just did. Please no. That is going to be its own element later that we will use a lot, and it will be very confusing if you use that as your element in sign. So this literally reads X is an element of A. Okay? Fantastic. So if not, so if X is not an element of A, we write the same symbol just with a cross through it. And I don't care which way you draw the cross, if you draw it that way or this way, it doesn't really matter to me. So that means X is not an element in A. So an example of this is if we let this set A be all the lowercase alphabet, at least our alphabet, okay? Then let's say N is an element in A and pi is not an element in A, okay? So that's one example. All right, so some more definitions. A is a subset of B if any element in A is also in B. In notation, this means if X is in A, then X is in B. Cool. So if you want to think about it, so you have two bowls. If this is A and this is B, any element you have in here, you can also find it in here. Okay. So how is this written? We write A like that, and then B. Okay. A is a strict subset if it's true that A is a subset of B, and there exists an element, let's say there exists an X in B such that X is not in A. Okay, so with our example again, this is A, this is B. Every element you have in here can be found in there, but there's at least one element over here that's not in there. Okay, so this is written, so it's the same as above, just without that line, and that'll make sense in a second. Okay, two sets are equal if, so let's say two sets A and B. So they're equal if A is a subset of B and B is a subset of A. You can also write it the other way. So here's how I like to do it. So that also means subset. So oftentimes when I'm trying to show that A equals B, I'll do this one and this one. So it just makes sense in my head which direction I'm going where. Maybe that sounds a little bit silly now, that since the names are so short, but sometimes we get some crazy looking sets. Okay, so two sets are equal if they're both subsets of each other. That kind of makes sense, right? So if these two bowls are the same, any element you find in here, you should be able to find in here, and vice versa. So, and it also works the other way. So if two sets are equal, then they're subsets of each other. And if two sets are subsets of each other, then they're equal. All right, some remarks. So let's talk about some of these remarks. So first thing I wanted to mention is that these are all different. Okay, so this and this one both have to do with intervals on the real line. So the hard bracket just means I'm also including that number. And then the soft bracket means I'm not including that number. But these little squiggly brackets, those are not indicating intervals. They're just saying the things that I'm listing in here, or the things that I'm describing, those are the elements of my set. Okay. And I also wanted to bring up, there's a difference between this and this, or similarly that. Okay. So with this one, it's only going to make sense if an element is on the left-hand side and a set is on the right-hand side. Or the other way that you could think of it, it's also, you can also do it the other way. That's fine as well. But it just, the forky part needs to be stabbing into the set, and then the element is holding the fork. I don't know. Okay, so and then for subsets, we can only talk about something being a subset of something else if the something and the something else are both sets. Although sets can be elements. Okay, so example 1 and 2, let's say. Okay, so 1 is not an element of that. Okay, this is an element of this, but it is not a subset. It's not a strict subset either. Okay, but this is a subset because now you have a bowl with 2 in it, and then you have a bowl with a tiny bowl with a lid on it where 1's inside, and then you have a 2. Okay, so every element in here is in here because the only element in here is 2, and 2 is in here. Kind of, I don't know, I hope my bowl analogy is making some sense. Okay, so then to launch off that, all these are the same. Okay, so it doesn't matter what order you put the elements in, it doesn't matter how many times you repeat the element. We're only talking about distinct elements. All right. Ooh, I might have not clarified that with cardinality. Let's go up. Let's take a look. The size of a set. Okay, so how about the number of distinct elements in a set. So the number of distinct elements in a set is called its cardinality. I apologize that I forgot to clarify it before that they need to be distinct. Okay, that's why we have these remarks so everybody can slip up on stuff. Okay, so as convention we use what's called Blackboard bold for sets we know and regularly use. So for example, the integers, whenever we have this like ... happening, that just means it goes on and on and on with the similar pattern that you saw before. And if it goes ... right into the set bracket, that means it takes that pattern on forever. Okay, but if you had like, let's say ... comma 7 bracket, and that means it ends at 7. Okay, but here we're going on to negative infinity and on to positive infinity. Okay, so as with integers, natural numbers, I don't include 0. You'll find some people do. Just for this class, I just find it easier to not include 0. You can think of them as the counting numbers. Unless you're a computer science major, then I guess you guys start counting with 0. Real numbers, that's just our number line that we know and love. And then Q is our rational numbers. So all numbers that can be written as a fraction of 2 integers. You know, a nice fraction, nothing divided by 0, none of that. So now I'm going to ask 2 questions, and then I'll answer them so you can pause it after I write them. Question 1, is the empty set a subset of A for any set A? Question 2, is A a strict subset of A? Okay, so take this time to pause. All right, so answer 1. Oh my gosh, I keep making an explanation. Answer 1 is yes. Okay, so whenever you have a bowl of elements, call it A. You can always choose to grab nothing. That's kind of how I think about it. All right, answer 2. No, because they're equal. So you can never find an element in A that's not an A, right? So sometimes just talking it out loud or writing it down or thinking through your thought process of what would need to be true for something to be true, that often helps a lot. Okay, so no, but A is a subset of A since A equals A. Okay, all right, excellent.